Advanced Basic. Introduction. Simple animation. Nested loops. Input get random numbers and other functions. Guessing game. Your role. Random graphics. $, and ASC functions. Introduction. The next few chapters have been written for people who have become relatively familiar with the basic programming language and the concepts necessary to write more advanced programs. For those of you who are just starting to learn how to program, you may find some of the information a bit too technical to understand completely. But take heart, because for these two fun chapters, Sprite graphics and creating sound, we've set up some simple examples that are written for the new user. The examples will give you a good idea of how to use the sophisticated sound and graphics capabilities available on your Commodore 64. If you decide that you want to learn more about writing programs in BASIC, we've put a bibliography, Appendix N, in the back of this manual. If you are already familiar with basic programming, these chapters will help you get started with advanced basic programming techniques. More detailed information can be found in the Commodore 64 Programmer's Reference Manual, available through your local Commodore dealer. For simple animation, let's exercise some of the Commodore 64's graphic capabilities by putting together what we've seen so far, together with a few new concepts. If you're ambitious, type in the following program and see what happens. You will notice that within the print statements we can also include cursor controls and screen commands. When you see something like CRSR left in a program listing, hold the registered key and hit the CRSR left/right key. The screen will show the graphic representation of a cursor left, two vertical reversed bars. In the same way, pressing registered and shows as a reversed heart.
Is that what you're supposed to do? Looks right. Cool. Let's run it from here. Yeah. Look at that.
The program will display a bouncing ball moving from left to right, and back again, across the screen. If we look at the program closely, shown on page 44, you can see how this feat was accomplished. Line 10 is a remark that just tells what the program does, it has no effect on the program itself. Line 20 clears the screen of any Informa tie-in. Tie-in. Line 25 prints 10 cursor down commands. This just positions the ball in the middle of the screen. If line 25 was eliminated, the ball would move across the top line of the screen. Line 30 sets up a loop for moving the ball the 40 columns from the left to right. Line 40 does a lot of work. It first prints a space to erase the previous ball positions, then it prints the ball, and finally it performs a cursor left to get everything ready to erase the current ball position again. The loop setup in lines 50 and 60 slows the ball down a bit by delay ing the program. Without it, the ball would move too fast to see. Line 70 completes the loop that prints balls on the screen, set up in line 30. Each time the loop is executed, the ball moves another space to the right. As you notice from the illustration, we have set up a loop within a loop. This is perfectly acceptable. The only time you get in trouble is when the loops cross over each other. It's helpful in writing programs to check yourself as illustrated here to make sure the logic of a loop is correct. To see what would happen if you cross a loop, reverse the statements in lines 60 and 70. You will get an error because the computer gets confused and cannot figure out what's going on. Lines 80 through 120 just reverse the steps in the first part of the program, and move the ball from right to left. Line 90 is slightly different from line 40, because the ball is moving in the opposite direction. We have to erase the ball to the right and move to the left. And when that's all done, the program goes back to line 20 to start the whole process over again. Pretty neat. To stop the program, hold down and hit for a variation on the program, edit line 40 to read 40 print bullet. To make the S, hold the shift key down and hit the letter Q. Run the program and see what happens now. Because we left out the cursor control, each ball remains on the screen until erased by the ball moving right to left in the second part of the program.
Let's run it from here. Yeah.